Hey guys, just another video in which we are going to power on through the index laws. Now in this one I'm going to have a look at index law number 3, and I'm also going to cover the zero power rule as well. So for the third index law, basically what the rule is saying is that if I have some number that already has a power and all of that has another power, then all I need to do is just multiply the two powers together. So I've got a to the power of m all to the power of n is equal to a to the power of m multiplied by n. Now for the zero power rule, simply what this rule is anything. So I've got a to the power of 0. Now this a could be any number at all, but if anything is to the power of 0, it always equals 1. So I'll do a couple of examples, having a look at index law 3 first. So for this one, I've got y to the power of 6, and that's all to the power of 2. So simply, I've got the same base, I multiply my powers together, so 6 times 2 is 12, so I'm left with y to the power of 12. Now sometimes you're not always going to be multiplying all the powers by this number. In this one I've got 2 multiplied by j to the power of 4, and it's just the j to the 4 that is to the power of 3. So what I'm going to do is I'm just going to leave that 2 by itself for now, I'm not going to touch him yet, and I'm multiplying my indexes together because it's index law 3. So it's going to be j is my base, 4 times 3 is 12, and if you want you can just simplify it by getting rid of that multiplier. So 2 times j to the 12 is just 2j to the 12, and you're done. Now sometimes you might have to mix in some of the other index laws. So in this next one we've got a squared to the power of 3 multiplied by a to the 4. So usually using I guess your BOMDAS rule, you need to deal with your brackets and your powers first before you deal with multiplication. So I'm going to deal with this section first. So it's a squared to the power of 3, so you multiply your numbers together. So it's a, 2 times 3 is 6, multiplied by a to the 4. Now for this one we've got the base is the same for the two of these, so we need to go back to using index law 1. When you're multiplying two bases that are the same, you add the powers. So this is going to end up being a to the power of 10, and that's the fully simplified version. Now sometimes you might have to incorporate some of the other rules. For this one we're going to have to use index law 2, which is a subtraction one when you have a division. So first of all, same as the last one, I normally deal with the brackets to the power first, just because of your general BOMDAS rule. So that's going to end up becoming y to the power of 3 to the power of 3 is y to the 9. If you multiply it together, divided by y to the 3. I'll just bring this up over here. And then we need to use index law 2, which is a subtraction one. So it's the same base, 9 take away 3 is 6, so I'm left with y to the power of 6. And you're done. Sometimes you might have many multiplications to do, and if you take it by a step-by-step approach, you'll generally get to the right answer if you're careful. Now for this one, what I'm going to do is I'm going to simplify this first, and I'll simplify this in the same step as well, and then I can try and combine these guys all together. So I'm going to leave x squared times y by itself, and I'm going to be multiplying that by x to the 3 to the power of 4. So you've got to multiply the 3 and the 4, so that's x to the 12 multiplied by y to the power of 2 times 2, which is 4. So now I've still got these multiplications that I can still simplify. I've got a couple of things that have the same basis, so I've got this x and x, and I've got a y and a y. So I'll go back to using index law 1. So x squared times x to the 12 is the same as x to the 14. So that's when you have to add them. You add the powers when you're multiplying. And I've got y, remember that's y to the power of 1 multiplied by y to the power of 4. So that's going to leave me with y to the power of 5. And what you'll find is a lot of the main mistakes that I find that people make is that you get confused between whether you're multiplying, your indexes together or whether you're adding your indexes together. And that'll come with practice. We'll do some zero power ones. So I've got 9 to the power of 0, so anything to the power of 0 is 1, so simply just write the number 1 there and you're finished. Moving on. Now for this one I've got 4y, and all of it is to the power of 0. So again, anything that's to the power of 0 just equals 1. Now, you can't rush into it all the time. Sometimes it's not all to the power of 0 like this previous one. So for the next one, I've got 5 multiplied by m to the power of 0. So it's only the m in this situation that has a power of 0. So it's going to be 5 multiplied by m to the power of 0, which is 1, and 5 times 1 is obviously just 5. Now for the last one, again, be careful with negative numbers and also your power signs. For the first one, I'm going to deal with this section first, and I'll also deal with this n to the power of 0 as well. So this is the same as the last guy. It's only the n that is to the power of 0, so I'm going to be left with negative 3 multiplied by 1 plus, now the 2 and the p both have an index of 0, so 2p to the power of 0 is just 1, so I'm just going to be left with a plus 1 at the end. And then you just need to use your normal BOMDAS rule or order of operations. So we've got negative 3 times 1 is negative 3, and I've still got this plus 1 at the end. And negative 3 plus 1, that's just going to give me an answer of negative 2. So just be careful, but the more practice you have, the quicker you'll get at these and the more accurate you'll be. Oh, well, thanks for watching. Catch you next time.